Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faiz Binuddin, and for today we are presenting about the preliminary technical proposal. So we are from group 4 and section 1. So this is for the group members, which is Yasin, Muhammad Rashad and Muhammad Ali. So the title we choose is Hvdc dry and wet test. So this is for introduction for the Hvdc and wet test. So basically the transmission, we know that the transmission line is a tall structure to support the overhead line. So the transmission line carry the high voltage to support bulk electric power from generating station to electrical subdivision. So next is transmissions are clarified into 4 categories, which are transmissions, terminal tension and transposition. So next is for the isolator, we can divide in 3 major of insulator, which is pin insulator, transmission insulator and string insulator. So basically, the insulator is to support and isolate electric conductor to in electronic component without allowing current flow through them. So next is translator is connected to the power generator or transmission line to utility poles and transmission tower, often referred to as an insulator. So the last point is they are carry the weight of the hanging wires while preventing current from flowing through the tower to the ground. So the 4 problem statement, we found the problem is the failure of insulator due to flashover that passes through the body of insulator. Beside of this, we insert the photo of the insulator and flashover. So next is to prevent this puncture under such condition, the thickness of the material are to be improved. So the AutoCAD software and finite element analysis (FEA) simulation software is used as a solver to analyze the performance. Next is the objective. So the first objective is to design and simulate the overhead line insulator transmission in console modeling software. And second is to analyze the performance of the insulator towards the electrical stresses and environment impact. The last point is to propose a suitable high voltage laboratory test setup to test the insulator durability to electrical stresses. So for the scope, divide by 3 as the objective. So first is to choose a prototype model for the this project is an digital-wide option of 132 kV. A glass insulator with a maximum length of 1540 mm, creepage and clearance of 4200 mm, and 175 meter area. The stacked and fitting option of the cap and pin, all of these will be designed by using AutoCAD software. Next is the performance of the insulator that has been designed using finite element FEA simulation software. And the last one is the project will focus on Hvdc dry and wet test. The prototype will be done and will be tested in detection laboratory, which will have a brief of safety, risk assessment, and code conduct. So that's all for me. Thank you.
My name is Muhammad Alif Basri bin Fari, and I will cover for the design planning. So all these points are presented into the flowchart in the actual report. So for this presentation, I will change it into the number in easier to present. So the first one is identify the load through the insulator. So for our load is the overhead transmission line that targeted on 132 kV system voltage plus string with a cap and pin insulator. So the second one is about the research study from the past. So this part is the importance to identify first what is the best parameter and the suggestion from the past research in improving the existing system. The third one is about the deciding the parameter and the design for the insulator. So from the outcome of the past project of the research from the past project study, we know what is the best parameter, what is the best suggestion, the improvement from the existing system that we take into our project. So the parameter also must be considering on the mechanical, electrical, and surrounding environment. So the next is about the draw the overview of 2D insulator designs. So in our design insulator, we will use AutoCAD in showing clearly the inside and the outside of the insulator itself. So next is analyze parameter of the insulator with their designs, performance, and several aspects. When analyze with the deciding parameter, so we can see the overall system operation and monitoring their performance. So last but not least is about the documentation. The documentation needed in discussing the problem and what happened to the overall insulator or overall system process. That's all. Thank you.
My name is Muhammad Rashad Rujani, that's me. My matric card number DE180200. So now I will present about the analysis of proposal design. Okay, this is our 2D drawing glass cat and pin insulator. We have cat, glass, cement and pin. We sketch this 2D drawing glass with the AutoCAD. Then this is cat and pin insulator with Akihon and gut ring. We have glass ring insulator, we have ball socket, gut ring and also Akihon for the 132 kV system voltage. Next is the insulator specification. The temperature can up to 50 degrees Celsius during summer day and 0 degrees Celsius during cold nights. For the solar radiation level, is up to 1000 Wm with high ultraviolet content. For the precipitation, up to 1500 mm of annual rainfall. For the humidity, up to 90% of the extended period of relative humidity. For the pollution, the minimum creepage clearance and up to 4 meter, and the wind velocity is 210 km per hour or 58 milli per second. Here for the material properties, we use glass. The type of glass is a soda lime glass, which shall be used for insulator, and it must be smooth and free of defect and blemishes that might shorten the insulator lifespan. We also use the cement. The adhesive used to bind the insulator and its related metalwork must be non-hygroscopic and have no effect on the metal fitting corrosion performance. Okay, this is our electrical and material parameter design insulator. We design with the minimum mechanical payload load, minimum mechanical residual strength, the diameter of the insulating part, spacing, nominal kinetic distance, pole socket coupling, punch voltage in insulating medium, dry power frequency, wet power frequency, dry lightning impulse with stem voltage, radio interference voltage, and also weight of the insulator. Okay, for the other parameter, we use Akihon and grading ring attached to insulator string is to protect the insulator in the occurrence of the flashover from being damaged or cracked by the arc heat. Next, the suspension clamp on the end of the insulator actually as a vibration damper that prevent any type of vibration such as avalanche vibration and oscillations. And we have the number of glass insulator cat and pin required for system voltage 132 kilovolts. For the 1 insulator disc, it can withstand 11 kilovolt. So to achieve a voltage of 132 kilovolt, we need 12 glass insulator, because 11 kilovolts times 12 is equal to 132 kilovolts. So the advantage of the Cat MP insulator is the high mechanical strength. The pin type insulator has a good crispage distance. The pin type insulator is simple and also less maintenance. It can be used vertically and also horizontally. So this advantage of the KM pin is should be used with the spindle. The pin of the insulator damage the insulator thread. The susceptibility of corrosion of the numerous fitting, and also the pin of the insulator is highly maintenance cost. For the active horn and guide ring, the advantage is the temperature can up to 12,000 Kelvin to protect the insulator from power add. The disadvantages, the coronic level is low, and also the pollution is not severe, and the duration of short circuit is too short, or the power not high and not high enough to cause the failure. That's all for me. Thank you.
Alright, to conclude, this project may help the students in terms of enhancing their theory of how insulator works in a transmission system. Besides, the finite element analysis, or also known as the FEA simulation, which is in the COMSOL software, is one of the preferred choices of method to simulate and design the system virtually for testing purposes. This is due to its features which enables the student to design the system easily for reliable output value. Moreover, in FEA, the students may learn to make a block diagram or plan the related flow process based on the methodology of the project. In simulating the high voltage and electrical field performances of the prototype, which we are going to do throughout the project. Lastly, the testing of the prototype may help the students for exposure of safety and risk assessment, which conducted in UTHM laboratory with guidance of tutor of the lecturer, or perhaps with the guidance of the technician of the lab for learning purposes for the students. That's all from us. Thank you.